Hello everyone, welcome back to my channel. In this video, we are going to see how we can create AI background remover using Python. We are going to use OpenCV for image processing, DeepLabV3. It is a deep learning model. It's a very famous deep learning model used for image segmentation. And also, we are going to use PyTorch, which will help us to run the AI model efficiently. So without wasting any time, let's get directly into the code. Okay, so before starting on our code, let me show you guys how we are going to process our video. So if you have a look at this video, this is the input video that we're gonna have. So this is the video of a girl writing something. So our goal is to remove everything that is there in the background and replace it with checkerboard, or we can replace it with some solid color like a green color or something like that, right? So if we replace it with checkerboard, it's going to look something like this. um, yes, we can create the transparent image, something like uh, this as well. Here we go. And then we can also, yeah, so if you had a look at this, so this is the transparent image with complete background gone. But the thing is that the mp4, we are saving our video files in mp4 format, and mp4 format is not really good with transparency. That's why we are using checkerboards or green screen, for example. And if I open this video, this is completely transforming the background with the green color. Okay, so this was just to give you guys a rough idea of what we are aiming for, right? So now let me show you guys how we can code this. All right, so here's the code. First of all, before starting how we have done this code, let me first of all tell you what libraries you have to install. So you have to install here OpenCV Python and NumPy, and then Torch Vision. I have already installed it, so I'm not gonna press enter here. And also, I'm going to recommend you guys to install all of this and all of this into a virtual environment, because it really helps you to not conflict with the other libraries. So if you do stuff in your virtual environment, it's always better, and it is going to help you avoid any installation issues. Okay, so with that said, don't worry about this command. I'm going to publish this in a GitHub repo where I'm going to document everything, how to run the program and what libraries you have to install. So I'm gonna uh, I'm gonna have your back over there. Okay, so if we see here, I have all I have already added the comments here just to make sure it is very understandable. So again, it's very basic stuff. We are importing all the necessary libraries. So CV2 is going to be for image and video processing, NumPy for handling arrays and numerical operations that we are going to do here, PyTorch and Torch Vision to load and run a deep learning model for background segmentation, and then OS for handling the file operations. Okay, so with that said, then we are going to initialize the background remover with the pre-trained segmentation model. As I said earlier, we are going to use DeepLab V3 and DeepLabV3 ResNet 101. We are going to use this model for image segmentation. So first of all, we will have to check, or we will have to let our code check if we have the supported GPU available in our device or not. My device doesn't have the GPU, so it is just going to run on CPU, but it's always better to run the programs, especially this AI ML programs on GPU, because it is going to be much faster as compared to be what it is there on CPU. Okay, so mine doesn't have CPU, but if you want to check, you can just run this code. If it has GPU, then it's gonna use the GPU. Otherwise, you will be running this program on CPU, which will be much slower, but it's not gonna stop anything. Okay, so with this line of code, it is loading the pre-trained DeepLab V3 model. So here, if you can see, it is, oops, what did I do? I have to do Control Z back. Yeah. Okay, so if I come back to my init, uh, which is over here, so self.model.deep is also DeepLab V3 ResNet 101. This is the name of model, and then it is going to use all these uh, pre-trained weights that have been used to train the model. Okay, and then it's going to assign that to your device, and then self model dot evaluation. Uh, this is what we are going to do for inference. I mean, to predict the outputs. So if we want to do that, we will have to set up the model into an evaluation mode so that it doesn't do any training. Okay, and then again, we will have to set up some pre-processing. Set up some pre-processing. Uh, if you know, we have to pre-process our data in order to get some better results from our model. So normally the pre-processing techniques includes normalization, standardization. We can do mean, mode, or median, but normalization seems to be the better option here, so that we are just using the normalized function, and we are using these values of mean and standard deviation to normalize our image. Now, you will be thinking from where we have gotten these values. These are predefined values which are mentioned in DeepLab documentation. That means they are saying that you have to use these values because these are the ideal ones if you want to pre-process the data. So these values are already tested, and that's why they are recommending you to use these values of mean in the form of these tensors. So this is a tensor, right? So initially we are going to have our data in a NumPy or array, and then we have to calculate it to the tensor so that our model can read that data. Okay, so I hope this is making sense till now, because next we are going to move on to the get person mask. Get person mask function is going to identify within the frame where the person is. Okay, so I'm here, so it is going to identify me, that okay, the person is here, and it is going to remove everything else which is there in the frame other than the person. So we just have to write that function here. Okay. Okay, so first of all, we are going to convert the BGR format of our image into RGB format. So OpenCV returns the image in BGR format, but our model is expecting it to be in RGB. So this is what this line of code is doing. It is converting the image into RGB using CVT color. Okay, once we have our image in RGB format, then we will have to pre-process the image for model, and we will have to add a batch dimension. Okay, so with this line of code, we'll have to pre-process the image, and then we are also unsqueezing our image to add the batch dimension. What do I mean by that? So let's say, let me erase this. I'm just going to write the same thing, but I will explain it along with that as well. So let's say we are having the image in the format CHW. Okay, so this is going to be the 3D tensor, channel, height, and width. When we unsqueeze it, okay, when we unsqueeze the image, we will be returning the image in the format of batch, number of batch dimensions. So number of batches means how many images are there in the batch. So let's say 10 images are there in the batches. That means we are going to have 10 C, H, and W. So simply we are just having the batch dimensions added into our input tensor. Okay. So now everything is set up in terms of input. Next thing we have to do, we'll have to ignore the gradients. So when we are training our models, we are using weights and gradients and everything to have the proper and accurate training of the model. But once we have trained the model, we don't really need to use it while doing the predictions or while doing the inference, right? So it is best to ignore those gradients to improve our computational power while running this model. So that is what we are doing here. We are ignoring the gradients using torch dot no grad. Okay, that means just ignore the gradients. And then we are getting the output. We are passing our input into the model, and then we are returning the output. Okay, so once we have our output, we will have to create a segmentation map. Okay, what do I mean by segmentation map? So in the segmentation map, each corners and or each pixels are going to have something, right? So let's say in the center of the image, it's the person, right? So for person, it is going to have the best accuracy score. So let's say this is pixel 35. So it is going to have the best accuracy score. Let me open the input video so that we can better understand it. Okay, so if you can see here, so these could be all the pixels around the video, right? So in the center, in these pixels, the accuracy score for the frame detecting it as a human is going to be the highest, right? And all the other ones are going to detect something else, or it is going to detect background, right? So this is how we are creating a segmentation map, and we are returning the highest score for all the pixels. Okay, and once we have created the segmentation map, then we have to identify which pixel has detected human, okay, or has detected a person. So we are using segmentation map is equals to 15. This is just a parameter value or a class ID defined for detecting the person. For car, I think it's 3. For dog, it's 2. It is already predefined in the model. Okay, so when we do this, it is going to create a mask which will help us identify where the person is within the entire frame. Okay, so now we have defined our get segmentation function, which is going to return the mask. And that mask will be something which is going to help us identify where the person resides within the frame. Now, the most crucial function for this implementation is going to be this remove background function. Okay, so first of all, what we're going to do, we are going to call the function that we have implemented above, which was get person mask. Then person mask is equals to self dot get person mask image. So we are going to pass our image, we are going to pass our frame of the video, and then we are going to ask it to return the person mask. Okay, so this mask is going to be the binary mask. Okay, so if it is person, for person, it is going to return 1, and for everything else, it will return 0. Okay, so this is going to the binary mask. Now our model expects it to be in the 3-channel mask for better blending. Okay, so we get the person mask and we stack it to create a 3-channel version. Okay, that is what we are doing here. And then this is just the implementation which is creating the checkerboards in the entire frame, right? So this is just that it is creating those boxes, gray and black and white or something like that. So this is just the code for that, and it assigns it as a background. Okay, if use checkerboard is set as false, then we are going to replace it with the green color. Okay, finally, after we have done all of this, we will have to blend the person with background by multiplying the image with the mask and the background with its inverse. Okay, so mask 3-channel, as I said, if it is person, it is going to return 1. That means it will be image into 1. Okay, see, the value of mask channel is 1, for person and zero for everything else for background, let's say. Okay. So if we put our values here in this line of code, if we do image into mask channel, then it is going to return us image because mask channel is 1 for the person and the mask channel is 0 for background. So 0 is going to be cancelled out. And then we are going to do background into mask channel 1 minus 1 is going to be 0. And if we do it for background, it is going to be 1 minus 0. Okay. So in short, we are going to have image plus background. So image is the blended image, which is only going to have the person, and the background is whatever background we have chosen, whether it is a checkerboard or it is a green background. Okay, I hope all of this is making sense. I know it's kind of complicated, but if you look at the code for quite a few times, if you try to practice it on your own, it will eventually start making more sense to you. Okay, and then the next function is just the function where we are going to process the single frame. Okay, I know if we are doing it in a real world application, we rather do it for the entire video other than choosing just a one frame to remove the background. But if I could have done the entire video, it would have taken more time to run. So just for the demonstration purposes, I have only added a single frame. So it is just going to select a random frame from the video and it's going to remove the background or replace the background from it. Okay, so let's go through this code as well. So first of all, it opens the video using this. Okay, cv2.video capture. It opens the video using video capture, and then we are getting the video properties where we are getting width, height, and FPS. And then we are going to make sure if the output directory exists or not. All of these things are pretty straightforward. And then we are going to skip to the desired frame. So we are going to define a frame number here just for this implementation. If we are doing it for some real project, we are not going to include this frame number thing within our project, obviously. And then once we have done that, we are going to read the frame, and then we are going to remove the background using self.remove background. This is just the function that we defined above. And then we are going to save that video as MP4 video. Okay, so this is pretty straightforward thing. In this, I'm also saving the image as well. So this is just a code for that. And here I have called all of our functions that we have defined above in our class. So I have done remover.process single frame. In this, I'm just going to keep the use checkboard as opposed to false, so that it creates the green background behind the person. And when I will do the use checkboard is equals to true, it is just going to go and create the checkerboard background. Okay, so I think this was everything for the code. Let me run this code and then we can see how it is actually removing the background. So my computer is relatively very slow, so it took quite a few minutes to run this simple program. But if I will open these videos, so this is the checker. Let me open it from here. I'll put checker.pg. So this is the image that it has created, and then this is the MP4 file, which is replacing all the background with the checkerboard. And then we also added the green background thing as well within our code. So this is the output. Okay, so I guess that was everything for this video. I do want to recommend you that check out this code. I'm going to post this code in my description. Practice it for 2 or 3 times, because when you are doing it for first time, or when you are watching the video, you might not be able to understand everything, but you will eventually understand it when you will try to practice this code. So I have tried my best to explain this line by line. So I would recommend you to practice this code if it does not make or something has not made sense to you during this video. Okay, so I guess that was everything for the video. Thank you so much for watching and good luck.